Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of 2D shapes. So as per the problem, a park is shaped like a rectangle with a semicircle at one end. So this is the rectangle and there is the semicircle at one end and another semicircle cut out of one side. So that's the semicircle that's cut out. Now we have to find the distance around the park and the area of the park. So let's start with the first part. So distance around the park. So distance around the park represents the total distance that has to be covered to go around the park. So it's basically the perimeter of the park. So for that, we'll have to measure all the side lengths around the park and add them to find the distance around the park. Now the distance around the park is made up of five distinct parts. So the first part is this length of this rectangle. So that's the first part. Now there is also the distance around this semicircle. So that's the second part of the distance around the park. Now the third part is the distance that one has to go around this semicircle. So that's the third part of the distance around the park. And then there is this part of the length of the rectangle. So that's the fourth part of the distance around the park. And then finally, it's the width of this rectangle. That's the fifth part of the distance around the park. So we have to add up all of these parts, the lengths of these parts, to find the distance around the park. So for the first one, the distance is 170 units and that's given to us in the problem. And then plus, now we have to find the distance around the semicircle. Now we know that for a full circle, the circumference or the distance around the circle is 2 pi r or pi d. So I'll write the formula on the board. So the distance around a full circle is 2 pi r or pi times diameter. Now in this problem, we are given the diameter of this semicircle. So the diameter of this semicircle is the width of the rectangle, which is 70 units. So since the distance around the full circle is pi d, so we can use this formula because we are given the diameter. So the distance around the semicircle will be pi d over 2. So if we want to use the value of pi as 3.14, so it will be 3.14 times the diameter, which is 70, divided by 2. Now we can evaluate this expression in our calculator. So 3.14 times 70 divided by 2 is equal to 109.9 units. So that's the value we'll use in our expression. So it will be 170 plus 109.9. Now we can analyze the third part of the distance around the park. So the third part is also a semicircle which has the same diameter. So it will be another 109.9 units. Plus, now we have to find the distance of the fourth part. So the length of the fourth part will be equal to the length of the rectangle minus the diameter of the semicircle. So we'll have to do 170 minus 70, which is equal to 100. So we'll have to add 100 because that's the distance of the or the length of the fourth part of the distance around the circle. And then we'll add the fifth part of the distance around the circle, which is the width of the rectangle and 70 units. So these are the numbers we have to add to find the distance around the part. So 170 plus 109.9 plus 109.9 plus 100 plus 70. So I got 559.8 units. So this should be the distance around this part. So now we have to find the area of the park. So that's the second part of the problem. Now in order to find the area of the park, we'll have to break up this composite shape into simpler shapes. So this park is basically represented by a rectangle to which a semicircle has been added on the right end and another semicircle has been taken out of one of its sides. Now these two semicircles have the same size because they have the same diameter. So basically the expression for area of this park can be written as, so total area equals, so area of rectangle plus area of semicircle However, we also have to subtract the area of the semicircle that has been cut out from the rectangle. So minus area of semicircle. Now since these two semicircles have the same dimensions or the diameter, so therefore their area will be the same. So we can cancel out these two areas. So they will cancel each other out. So we are left with the total area as just area of rectangle. So there is a very important concept we need to understand about this problem. So since the two semicircles have the same area, so adding one semicircle and then taking away another semicircle from the rectangle, so it doesn't change the area of the park from the area of the rectangle. So now we can calculate the total area. So the total area will be equal to the area of the rectangle, and the formula for that is length times width. And the length of this rectangle is 170 units and the width is 70 units. And now we can multiply these numbers. So 170 times 70 is equal to 11,900. And the unit is the square unit. So this should be the final answer for the area of this park. So these are the steps you have to keep in mind to solve a problem like this one. So since it's a composite shape, we should be able to identify which parts of the shape make up the distance around the park. So it's better to label them so that way we don't miss out on any of the parts when we are calculating the distance around the park. And for the total area, we again should break up the shape into simpler shapes and then combine the areas of the simpler shapes to get the area of the composite shape. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.